Hello. You should see the desktop now. Let's see. Okay. Is the desktop visible? Do you hear me? Is everything seem okay?
Yeah.
Okay,
Yes,
great.
sir.
Thanks. Pardon me? Okay. Let me pull up one more list. Okay. So first, let me remind you that next week, the 12th and the 13th are fall break. So we won't meet again until a week from today. So the next class will be next Thursday. Okay. Uh, Today we're going to start talking about loops. Okay. So we're going to start talking about loops. And then, so we're going to be doing this introduction to loops. And then there's a reading assignment for next week, which will be more about loops. Take us a while to do loops. And then I put a list of coding bat problems here. These are problems involving string methods, if statements, and logic. So the stuff that we've in the last chapter. Okay, so this is a good summary of what we've seen from the last chapter. And these are very good problems. I think you should try all these problems because the most important way to learn this stuff is to keep using it. Okay, so these are if you go to one of these, they're from the string one section. So they're their introductory string problems and logic. So it's a combination of strings and logic. These are kind of pure logic ones. These are strings using logic, but there's no loops. The idea is here is there's no loops. Now there's a lot of problems in this section, and I picked what I thought were good ones that involved an interesting use of ifs. Like many of these don't need any if statement or any logic. There's actually quite a few in here that you can do only using a couple string methods. So I picked the ones that I thought were good practice in using a combination of all three of these: string methods, if statements, and logic. So I picked the ones that are good summary for us. Okay, so these are all good problems. They're all nice challenges. You should try to do one of these a day. I mean, a good way to practice this would be to do one of these a day. Um, you if you can do them in 5-10 minutes, that's great. Then you're really learning. Yeah. If it takes you more than 15-20 minutes, then the time spent doing these is reinforcing what it is you need to figure out. Okay. So, but the only way to know that you're really getting this stuff, and being able to use it is to use it. Yeah. So the only way to make sure that you're really learning this stuff is that you're using it here. And these problems are very much like what programmers really do. The problems all look a little bit silly. They kind of tend to look a little bit silly, but they're not as silly as you might think. They actually make you think in the way that programming problems really need to think. Uh, no matter what you build in computer science, it's made out of lots of little things. And the little things look a lot like this. So even if you build a game, the game is built out of lots and lots and lots of little pieces of logic. And the little pieces of logic look a lot like these things. So you have to be able to write these little things to build big things. So I really think these are the best thing you can be doing really is to be solving these problems with encoding that. Okay. All right. So uh, let's start talking about some looping stuff. Okay. Now, I'm missing a file on my desktop. Um, oh, let me just try to remember. Okay, there was an example I wanted to start with. Let me see if I can remember where I put it. I thought it was, I think think I moved it over here. Okay, let me check. Yep, okay. Let me start Dr. Java. And let's look at this example in Dr. Java. Okay. All right. Now, this example is actually what we were doing earlier this week and last week. It's a problem. It's some code practicing using combinations of Boolean expressions. So it's this idea of compound Boolean expressions. So the program creates a scanner, prompts the user to enter a number, reads the number from the user and gives it the name n. So n is the number read from the user. Then it does. Here I listed what it's going to do with each of that with the number n. It's going to check, is the number n greater than 10 and is it less than 20? So is the number between 10 and 20? Is the number less than 10 or is it greater than 20? Is it not the case that the number is less than 100? So another way you ask that is the number greater or equal to 100? Okay. Is the number equal to 25 or is it 75? Okay. Now what I do is here I just, as a comment, said this is the things I want to check. And then down here, they're checked, and each one is printed out. Okay, so if you compile this and then run it, so I'm going to enter number 34. And I hit enter, and I find out that 34 greater than 10 and 34 less than 20 is false. 34 less than 10 or 34 greater than 20 is true because this one is true. Okay. And is n less than 100? That's true, but then I take the opposite of true, so I get false. So it's false that it's not less than 100. Okay. And then, is it 25 or 75? And the answer is false. Okay. Now, here's the question for us. What if I want to ask the user again? So I got one number from them and the program ended. So started here, created the scanner, asked them for a number, got the number, made these checks, and then I'm done. What if I want to ask again? Well, I can run the program again. Well, I don't have to compile it. Yeah, I just need to. Okay, so I can run it again. Now my numbers, there's a number, there's my answers. Then I could run it again, type in another number. There's my answers. But why not have the program repeat itself? So this is what brings up the idea of a loop. I'd like to just have this program just repeat itself. So that's what loops are for. So here's what it looks like. I want to repeat these steps of asking the user for a number and then processing their number. I don't need to repeat this thing. Once I have a scanner, I can keep using it. So to repeat something, you use what's called a while loop. Okay, so I write while, and here I'm just gonna write true there, and then I put a brace. Then this is what's inside the while loop. I want to repeat everything up to here. Now all the stuff I want to repeat is inside of the while loop. Okay, but I should indent it now because it's now inside a pair of braces. So if I highlight that, and Dr. Java will do the indentation for me. I don't have to actually do it myself. If I highlight what I want to be indented and hit the tab key, Dr. Java tabbed it in. Dr. Java indented it for me. Okay, so if you highlight a bunch of code and hit the tab key, Dr. Java figures out what the indentation should look like. So a good example of that is if I goof up the indentation a lot, if I highlight this in Dr. Java and hit tab, it'll fix all the indentation back for me, which is real nice. I mean, before you turn in a homework assignment, you should do that. You can just copy, highlight your whole program, hit tab, and your whole program becomes magically indented properly. Okay, so it doesn't matter how much you might goof up the indentation. If you can highlight the whole program, hit tab, and Dr. Java will fix it for you. Okay, so now I've got this thing in a while loop. Now, here's something. Think about if I did this. What does that do? What if what does this piece of code do here? How's this program going to behave if I run it? What does an if statement do?
Checks Boolean.
It checks the Boolean. Now, the Boolean is the word true. So true is true. And if the Boolean is true, what does this thing do?
Runs through what's in the brackets.
Yeah, it does what's in the brackets and then done. Okay. And if I put, so this program will do this one time. And what if I put false in here? What happens now?
It skips.
It skips it. Yeah, so it'll skip all this. Now, here's the difference between true, if and while. While is very similar to if, but what while does, when you spell it right, what while does is check the Boolean. If the Boolean is true, it runs through this code, but then it goes back and does it again. And it checks the Boolean again. And if the Boolean is true, it runs through this code. And then it goes back and it checks the Boolean again. And if it's true, it runs through this code. Since I have the word true here, what's this program going to do?
Infinite loop.
Infinite loop. So it's going to keep prompting the user over and over again, which is, in this case, it's probably all right. Okay, so what I'll do is I'll run this program. There's my first number. Okay, there's my output. Okay, now I'm asked for a second number. There's the results. I'm asked another number. There's the results. And I can keep doing this for as long as I want. But at some point, I get sick of this. So, now I can't stop the program by any logic in the program, but I don't have to sit here and do this forever. Dr. Java will let me stop this program by clicking the reset button up here. The reset button up here, we're going to see this is going to become useful for us. When we have a program that's running forever, usually that happens more by accident than by design. Here it's by design that the program runs forever. More often than not, when a program is running forever, it's because you made a mistake in your logic. But if you've got a program that's running forever, Dr. Java will let you hit the reset button. It asks you, are you sure you want to reset the program? You say yes. And that stopped the program. Okay. All right. So now what if I put false in here? What does this program do now when I run it? Whoops. Oh, Java actually, okay, what is this program supposed to do? What would I expect this program to do when I try to run it?
Nothing, because the condition is false.
Yeah, nothing. So it's going to skip over this. In fact, the compiler even notices that and says, this doesn't make any sense. You're trying to compile a program that does nothing. and it points out that it won't actually let me compile this. Yeah, the fact that I wrote a program that does absolutely nothing is considered an error by the Java compiler. It notices that you've said while false, false means skip over this. There's nothing else left. So it says that, you shouldn't be doing that. Now here, let me do something here. Let me do something when that loop is over with. Okay, so if now I'm saying while false, then the last thing I'm saying is print by. What should this program do? Okay, now notice it will compile now. No, let's see. Oh, it still doesn't like the fact that, yeah, it won't let me. It's still telling me that I wrote all this code and it's never going to execute. So the compiler actually won't let me do this. It's smart enough to say, why are you writing all this code that won't work? Okay, so it won't, it should, if this was C or C++, it wouldn't be like this. You would just have this thing saying, skip all of that and go straight to here, okay? So this is an infinite loop, and it'll just keep doing this, go back, do this, go back, do this, go back. And if you write false here, Java compiler kind of says, well, that's kind of dumb. You're basically just skipping over all this, so it gives you a warning and says that doesn't really make sense. So the compiler doesn't like that. It says you have unreachable code. You have a bunch of stuff here that you would never get to, so it doesn't let you do that. Okay, now let's try some other things. What if I want to prompt the user 5 times? So here's how I'm going to do that. I'm going to create a counter. I'm going to call it, I'm going to create a counter, and I'm going to set it equal to 0. And I'm going to check if my counter is less than 5. Then down here, at the end of prompting the user and printing the results, I'm going to say count 1 input. So counter equals counter plus 1. Okay. So what have I done? I want this loop to do 5 loops. So I need some logic in here that'll somehow count to 5. But the logic has to be kind of broken up into several pieces. I need to create a counter variable, check the counter variable here, and count the counter. This count could be anywhere inside this loop. I could have put it right at the beginning. I could put it at the end. It really doesn't matter if I put it down here at the end, or if I wanted to, I could put it up here at the beginning. I need to count the fact that I've done this loop 1 time. Okay, so I'll leave it at the bottom. Okay, it doesn't really matter if I count it at the beginning or count at the end, or if that matter, I could count it in the middle, but I'm going to count the loop. Now, I start with the counter 0. When counter 0, 0 is less than 5, so that's true. So you execute what's inside here. You get to the end and you add 1 to counter. 0 plus 1 is 1. You go up here and now you have 1 less than 5. So if I keep track of the counter was first 0. Now it's 1, and I do what's inside here. When I get to this bottom line, I'll have 1 plus 1 is 2. I'll go up here. Counter is now 2, and 2 is less than 5. So I'll go through here. Now get down here. 2 plus 1 is 3. Go up here. Counter's 3. 3 is still less than 5. That's still true. I'll do all this. I'll get 3 plus 1 is 4. 4 is less than 5. So I'll go down through here. I'll get 4 plus 1 is 5. Go up here. I have counter now equal to 5. And what about 5 less than 5?
False.
False, because it's a strictly less than. So now I skip over and I say bye. Now, here's one thing that's interesting. see how many numbers the counter went through? It went through 6 numbers. 0, 1, 2, 3, 4, 5. Counter went through 6 numbers, but the loop was only done 5 times because on that last number, you skipped over the loop. Okay, you skipped over this code. But it's important to see that actually the counter variable took on 6 values. Now, if we go through and compile and run this, there's our first input, give it a number. There's our second input, give it a number. There's our third input. There's our fourth input. There's our fifth input. Our fifth input, we got our answer and then said bye. See, we did 5 inputs. 1, 2, 3, 4, 5. Okay. All right, so now I've got a way of repeating code. Now I've got a real simple way of repeating a bunch of code. In fact, in some languages, this word while is written repeat. It really varies from language to language. In some languages, it's written as repeat. Did I spell that wrong? Yeah. In some languages, it's do. Do this so many times. Java likes to use the word while because that's the word that C and C++ chose. Java did everything the way C and C++ did it. But this idea of looping like this, some languages call it a repeat, some people call it a do, some call it a while. You read it as while this thing is true, do what's in here. Compared to if. If this thing is true, do this once. Now it's while this is true, do this. And one thing that's real important is, look, I mean, here's the outline of if, looks like this. If Boolean expression, do what's in there. That's one kind of if statement. And we also had another kind of if statement. If it's true, do that stuff. But you also could say, but otherwise, do this other stuff. Okay? The while loop's more like this one. And it looks like this. You say while Boolean expression. Okay, that's a single Boolean expression. That's why I put the underscore there, because it's one thing that's either true or false. Now it could be using ands and ors, so it could be lots of little things all combined into one complicated thing, but it's really one complicated thing. So if I write something like this, that's not 2 Boolean expressions. That's one Boolean expression in 2 pieces. From the point of view of the Java language, that's the Boolean expression made up of 2 pieces. Okay, so the if statement, as far as it's concerned, there's just one Boolean expression inside of it. Same with while. There's just one Boolean expression inside there, but it could be built up of lots of sub expressions using ands and ors. Okay, so if this is true, do what's in here. On the other hand, if this is true, do what's in here, otherwise do what's in here. Okay. The while one says, while this is true, do what's in here. And there's something a little bit tricky here that wasn't in the case of this. Inside here, you do something. That do something should affect this expression. What if this do something has nothing to do with this expression? What's that going to lead to?
An infinite loop.
Yeah, because if this thing is true, but this doesn't affect it, you've got an infinite loop because this thing won't change. That's how you accidentally get infinite loops. You forget to somehow have this affect this. So unless you want an infinite loop, which is very rarely the case, you better have this thing do something that affects this thing here. Now that's not true here. There's no reason why the do something in here should have anything to do with this thing here, because you're not going to repeat this. So you ask if some condition is true. If it's true, you do this. There's no reason why this should affect this. These two things don't have to, they should be related probably, but this one does not have to change this one. This one better change that one, or I got an infinite loop. Okay. Now, you know what? Here's something. Java doesn't have this, but notice how you have the, if this is true, you do that. If this is false, you do that. Here's something that some people thought was clever in a language. While this is true, you do this. When this is false, you finally do something else. Java doesn't have this, but there are a few languages that have this. So this is do something, and this is do something, do something else. Okay. Now here you do either this guy or you do this guy. In this case, languages that do this, and this is actually kind of clever. Java didn't think, C++ didn't do this, so Java didn't do it. The idea is you do this thing repeatedly, followed by one of these. So unless this thing starts out false, like what if you came in and this thing was false to begin with, then you do this one time. So you could do this one several times, but you do this one time. Okay. Notice that in this case, you do either this or this. When languages have this kind of thing, you do this one possibly 0 or more times. If this thing starts out false, you don't do this one. But if this thing starts out true, you do this one a few times, but you always do this one at least once. And it's referred to as finally. Java didn't think that was useful. Okay, there are languages that think you should have, just like you have if without an else, you have if with an else. Why not have a while by itself and a while with a finally, something that cleans up after the while loop? Okay, there are languages that do that. Okay, but Java doesn't. Java didn't think that this was useful enough, so Java only has this one. So this is not in Java, or C++, or I don't think JavaScript has it either. Okay. All right. So these are the kind of ideas that programming languages have these things built into them, but not everyone agrees on what they should be called. For example, it doesn't have to be called while. It could be called repeat. Repeat's not a bad name for it. It's saying repeat this as long as this is true. Though this reads real nice. While true, do this. While true, do this. So it actually reads pretty well. While true, do this. And finally, when this guy finally turns into false, because this thing has to affect this, when it finally gets false, do this something else. But Java doesn't have that. Okay. Okay. All right. So I have to I can't this is not really Java here, so I have to close that. Otherwise, I won't be able to. Remember, I'll show you in a minute. Remember, Dr. Java compiles all the files you have open. When I try to compile this one's going to cause me a problem because that's not a legitimate Java program. So I'll have to close it. It's kind of a weird fact of Dr. Java that it tries to always compile every file you have open. Okay. Now, let's see. Now, this thing was running 5 times, even though the number inside of here went up by 6 values. Okay. Now, here's one thing that makes this tricky. Now, how many times do I ask the user for input?
6.
6 times, because, but then what happens to counter? How many values does counter take on?
7.
It'll take on 7 numbers, because see, now suppose counter is 5. So 5 is less than or equal to 5. You do the work. You get down here, 5 plus 1 is, now we tack on a 6 onto this list, but 6 is less than or 6. This turns out false. So now counter goes through 6 numbers, but we execute what's inside here 5 times. Okay. On the other hand, suppose I do that. What numbers does counter go through, and how many times do I actually prompt the user? How many times am I going to prompt the user?
5 times.
5 times. Now notice I lose this 0 at the beginning. There is no 0 number. So counter starts at 1, and then it goes to 2, then 3, then 4, then 5. At 5, it's still true. You get down here, counter becomes 6, and then this is false. So I go through 6 numbers, and I prompt the user 5 times. Notice that this stuff can be tricky to read. Like for example, now, how many times does it, how many numbers does it go through, and how many times does it prompt the user?
5 numbers, and it prompts the user 4 times.
Yeah, 5 numbers and prompts the user 4 times. Okay, notice that you can't take these numbers too literally. If I wanted to, if I asked, if you want to know how many times the user is prompted, many people naively look at that number. But what do you really need to look at? Like, people will think, oh, you're going to prompt the user 10 times.
You have to see where the counter starts.
Yeah, okay, you got to check where the counter starts. What else do you have to check? There's one other thing you have to check. Where did the counter start?
How much it adds each time.
That's another thing you have to check. What if I added 2s here? That'll affect things. And there's another thing you have to check. So you have to check, where did it start? How much did you add by? And what else do I have to check? There's 4 things to check. This number here, that's 1. Where I started, that's 2. How much I add by, that's 3. What's the 4th thing I really need to pay attention to? Because it does affect how many prompts there are.
The symbol between the counter and the number, whether it's less than or less than and equal than.
What relation you use there? Are you using less than or equal? Because that changes it by 1. That changes the amount of, that changes the number of prompts by 1. So you have to, so if somebody, this is really common mistake that a lot, especially people starting, they see a while loop like this and they go, oh, it's gonna loop 10 times. And then they don't realize, no, you have to check way more than that. That's just one of 4 things you need to check. What did the counter start with? How did you compare it? Where is it ending? And how much did you increment it by? You got to check 4 things. So for example, if I start with 0, make that a less than or equal, and go up by 2s. Okay, I don't even know how many times this thing works. Let's trace through it. Let's do what we call a trace. We could run it, but what we want to do is learn to think about it. Okay, so we start just tracing. Counter 0. So I start with a 0. So I start with a 0. 0 is less than or equal to 10. Go through here, do the prompt. 0 plus 2 gives me 2. So my next number is a 2. So I come back up here with 2. 2 is less than or equal to 10. Do a prompt. 2 plus 2 is 4. My next number is a 4. 4 is less than or equal to 10. Go down here. 4 plus 2 is 6. Now I can see that I'm going up by 2s. So I'll go up to 6. 6 is less than or equal to 10. Go up to 8. 8 is less than or equal to 10. Now let's think carefully here. 10. 10 is less than or equal to 10. So I go through here, but now I do 10 plus 2 is 12. And I come back up here, but this is false. Okay, so I go through 1, 2, 3, 4, 5, 6, 7 values of counter, but how many times do I prompt?
6 times.
6 times, which is weird. Because if you go from 0 to 10 by 2s, you might think 5 times. But if you do a careful trace, you see that now let's check. Let's go ahead and run it. We should get 1, 2, 3, 4, 5, 6 prompts. So let's try it. Compile it. Oh, see, now here's my problem. See, I have both these files open, and I want to compile this one, and Dr. Java stubbornly wants to compile this one, even though to me it's in the background. So I have to see, Java won't. That one's not going to compile. It's not really legitimate Java. So I got to close that one to be able to compile this one. So compile this one. Now run it. Let's check how many inputs we get. There's our first input. There's our second input. There's our third input. There's our fourth input. There's our fifth input. There's our sixth input, and bye. We're done. So we were right. We traced it correctly. Counter went through 7 numbers, but the body of we call this the body of the while loop was done 6 times. While loops are way harder than people give them credit for, because if you write a while loop and you ask somebody how many times does it loop, they actually have to check 4 things. Where did your counter start? How did you compare your counter? What is the limit you put in here? And what about the thing down here? Like, here's a trick question. How many times does it loop now? I'm changing from, whoops. I'm changing this from 10 to 11. Let's see. What happened here? Let me see. I want to go back to where I was. I hit. Okay, I was at, what was I before? I was at 10, right? And we
And
went.
it went through it 7 times.
This is what we were at a minute ago. Somehow I did something on the keyboard that was funny. We went through it 6 times, right? So we went through 6 times. We had 6 prompts, 6, 5, 4, 3, 2, 1. That was 1, 2, 3, 4, 5, 6 times. And the last one didn't count. The counter took on 1, 2, 3, 4, 5, 6, 7 values, but we went through this code 6 times. Okay, what if I change that to an 11? So I increased 10 to 11.
Still going to be 6 times.
Why?
Because 12 is still not less than or equal to
Yeah,
11.
see, my stopping point's in between these 2 numbers, and that didn't really matter. My counter goes from 10 to 12, and 11 doesn't, 11 isn't going to be 12 yet. If I did this, I actually pick up another loop. Okay, but this doesn't change. So this and this do the same thing by the logic of it. See, I can't just look at that number and say you raised that number, so you did another loop. This did 6 loops. This does 6 loops, but that'll do 7 loops. So it's tricky, very tricky. Okay. Now, what if I decrease this to 9?
5 times.
Now I got 5 loops. Yeah. Increasing it didn't change it, but decreasing it by 1 changed it. Because now when I get the counter will go 0, 2, 4, 6, 8, 10. 10 is larger than 9, and I'll stop, and I won't ever get to 12. I won't ever get to 12. 10 will be my last value of counter, but I'll only do these are the ones that will cause prompts. 0, 2, 4, 6, 8 will cause prompts. The 10 in counter will be greater than 9, and it won't cause a prompt. Okay? Notice how tricky this stuff is. While loops require real attention to detail. Okay, and in the real world, you do get problems like this. The problems can be very, very tricky like this to figure out exactly how many times you're looping. It's not the case that people write real straightforward code. Quite often you have funny starting values, funny starting ending values, and you're incrementing by something other than just 1. So it's not at all uncommon to be doing something like this. Okay, so you have to check where you started, how you compared, what your stopping point is, and how you increment by. So you've got to check 1, 2, 3, 4 things to know what that loop does. Okay. All right. Okay. So that's the basic idea of while loops. Now, notice that this is the important thing that affects what's in this thing here. Remember, we said when we were looking at this table, it's very important that do something has some kind of effect on the Boolean expression. If do something doesn't affect this guy, you have an infinite loop. Okay, and over here I would get that, like if I comment out this, now what happens? Why do I have an infinite loop? I got my counter starting at 0. I'm checking for it being less than 9. What's wrong?
Because they didn't change the number at all, so it's the same number that returns the loop.
Yeah, the counter never changes now, so I'm just going to keep looping forever. And it's real easy to make this mistake. Yeah, when you start writing more code, you're going to start writing code using loops, like in the next homework assignment. And if you do like some of the coding bat problems, it's really easy to forget. Excuse me. It's actually easy to be writing your logic and then forget this one line at the bottom, for example, and forget to change the number. It's actually real easy to make these little mistakes. And then all of a sudden, you've got an infinite loop. Okay? So, from the point of view, the thing you have to remember is whatever you're testing for here, whatever it is you're testing for, somewhere in here better be something that updates that test. Otherwise, you have an infinite loop. Okay? Okay. Now, let's switch from while loops to another kind of loop. There's another kind of loop called a for loop, which actually turns out to be another version of a while loop. It turns out that the way Java works, the for loops are actually just kind of convenient ways to write while loops. Okay, so let me show you the syntax. The for loop's going to be written the following way. You're going to write for. Then there's going to be a pair of parentheses, a lot like if and a lot like while. And then there'll be do something, a do something inside of the for loop. Okay. But what goes in? Okay, actually, let me back up a little bit. And if you notice here, the pattern, create a variable, check its value, increment the variable. I can write that as a pattern. Here's what while loops often look like. Okay. Initialize some variable, then while test, while some test, do something, then increment the variable. Okay. This is the pattern we just wrote for our while loop. Initialize something, test it, do something, then increment it. Okay. Initialize, test, increment. And huge numbers of while loops are written that way. Start with something, some kind of counter. Check if you've gotten to where you want to stop. Somewhere in here, you better change the counter. Otherwise, you're going to loop forever. Okay. That's the pattern.
I have to go to.
What? Okay. You have a question? Okay. That's the pattern that a for loop wants to summarize for us. So here's how a for loop works. A for loop comes in 3 parts that are separated by, inside these pair of parentheses, there's 3 parts. Unlike, notice that inside the if I said there's 1 Boolean expression. Even if you use an and or an or, altogether that's 1 Boolean expression, 1 Boolean expression, 1 Boolean expression. The for loop's actually got 3 things in it. This thing is going to be called initialize. This thing's going to be the test. It's the Boolean expression. And then over here will be the increment. What a for loop does, it just lets you take this thing, and this thing, which are kind of scattered around, and put them all in one place. That's all it does. It's really a while loop, just written in a better way, in a more compact way. Most while loops need to start some kind of counter off here, test whether the counter's reached its limit, and at some point you got to make a change in the counter. So you need to initialize, test, and increment your counter. And that's what a for loop does. For loop says, put the initialize part there, put the test part between the semicolons, and put the increment part after the second semicolon. Okay? That then is called a for loop. So if I go over here, I turn this guy into a for. I'm going to comment out that and comment out that, and I'm going to rewrite this guy as a for loop. So I'm going to put a for here. To make it a for loop, I take this, put it there. Take this, put it there. And then take this, put it there, close my parentheses. Okay, that was the for loop. Oh, and then I don't need this down here. Okay, now I turned what was a while loop into the exact same for loop. Okay, I just moved the initialize into the first part of the for loop. The test becomes the middle part of the for loop. And that increment that was at the bottom of the for loop now is put up at the top, so it's easier to see. It's easier to notice that. Oh, remember we said you had to check all 4. You remember we said you had to check 4 things, and now here's the 4 things. Where did you start? How are you comparing? Where are you ending at? And how are you incrementing by? Now, all 4 things I need to analyze are right there inside the first line of the for loop. Makes things a little bit easier. Okay, so everything that I need to test, everything I need to think about, everything that I'd want to understand about this for loop is up here, so I can see where it started, how it's being checked, how it's being tested, and how I'm incrementing the counter in between loops. Okay, so this for loop was C. What did we say the last time when we do it 0 to 9? This one went 1, 2, 3, 4, 5 loops, ending with counter is 10, but it actually the counter went through 6 numbers, but we looped 5 times. So now we close this guy. I don't want, okay, and then save this one. And now the for loop should act exactly like the while loop. There's one input, there's the second input, there's the third input, there's the fourth input, There's the 5th input, and then I'm done. So I got my 5 inputs. That was from 0, 2, 4, 6, 8. That was my 5 times. Now, the counter was going through 0, 2, 4, 6, 8, and each time for one of those values, I got a prompt. Then the counter hit 10, but 10, well, the counter hit 10. So now these things are over here. Counter's still not, here I'm keeping track of what counter did. Counter started at 0. Counter went up by 2s, 0, 2, 4, 6, 8. 8 was still less than 9, so I went through, and then I did one last increment, which hit me up to 10, but then this thing failed. So I didn't go through and prompt the last time. Let me draw you a picture. There's a picture that goes along with for loops. Okay. Here's my for loop. I'm gonna superimpose it on a picture. And this picture's in a lot of books, but it's a good thing for us to see where it comes from. Okay. There's my for loop. Okay. Here's how you should think about a for loop. Your code comes in. This is the flow of control idea. Your code comes in and it flows to the initialize first. You do initialize first. Then after you've initialized, you flow to the test and you do the test. If the test is true, you flow from there inside here and do something. After you do something, you flow over to increment and you make the change. Then after you've done the increment, you flow back to the test. And then the loop is test, do something, increment. Test, do something, increment. And there's the loop. Notice that initialize is not part of the loop. And that kind of made sense in the while loop. In the while loop, you didn't think of this as being part of the loop. See, it was before the word while. So the loop was test, do something, increment, test, do something, increment. Okay. And here it's not quite so obvious. Here you need this kind of like, you have to think. You come in and do the initialize once, then you do the test, then you start the loop. If the test is true, you drop into the loop. Do something, increment, test, do something, increment, test, do something, increment, test. When test is false, you drop out of the loop. I don't usually draw that arrow because it kind of confuses the picture, but when test is false, then you drop out of the loop. So this arrow is for true. So it's worth putting down here that this arrow is when you have true. Okay, when the test is true, you do this arrow part here. Okay, so initialize, test. If it's true, do something, increment, test, do something, increment, test. So that's the picture that people have in their mind of what a for loop does. Okay, and when you're seeing it in code, you have to kind of convince yourself to remember, do this once, then do this right away. That test determines whether you go in here at least one time. After you've done everything that's in the braces, then you go over to here. Then after you've done that, you go back to here. And if it's true, you go in the braces. So you read this here, here, down here, back over here, backwards. Now you start reading backwards at some point because you read it starting, read this piece, read this piece, read this piece, then read this piece, then go back to this piece. And if it's true again, this stuff, then this stuff, then this, then back to this, then down in here. Okay. Now, there's a problem with for loops that makes them even weirder. That's perfectly legal. Can anybody see what happens in my for loop now? I can put anything I want inside here. Oh, remember we said that this do something, I'm sorry, that this do something better have an effect on this guy? Because if there's nothing in here that affects this, then you have an infinite loop, okay? Notice that that's not true in the while loop case. Is it absolutely necessary that this thing affect this thing?
No, because you got the increment
Right,
built
yeah,
into it.
exactly. See, the increment's over here. So now this thing does not have to affect this thing, but there's nothing to stop you from having this thing affect this thing. And people almost always do. It's real common in for loops for there to be something in here that actually affects this test, which is another thing that makes for loops really tricky. So now go back to my example. What have I done in this piece of code here? Now my for loop looks like this. What's my trace look like?
Is it going to add 2 twice?
Yes. So it does what? It does, what's my trace over here look like?
It'll go by 4s.
Up by 4s. The trace will look like this. 0, 4, 8, 12. I'll actually loop 3 times. Let's check it. Counter starts at 0. Okay. 0 is less than 9. Do everything in here. 0 plus 2 is 2. 2 plus 2 is 4. Now I go over to here. Is 4 less than 9? Sure. Do it again. 4 plus 2 is 6. 6 plus 2 is 8. Now I'm going over here. Is 8 less than 9? Sure. Do this again. 8 plus 2 is 10. 10 plus 2 is 12. Is 12 less than 9? No, I'm done. Counter went through those 4 values up by 4s, and the body was incremented. The body was done 3 times. Let's just check, compile, run. First number, second number, third number. That's it, no more numbers. For loops can be nightmarish to read because now you have what? Check this beginning value, check this ending value, check how it's being compared, check how it's being incremented, and what else?
How it's being incremented again.
Well, you have to, yeah, but where? Where do you have to, you look 1 place, 2 places,
Oh, within
3
the body.
places, 4 places. Where's the 5th place to look?
In the body of the loop.
Yeah, the entire body of the loop, because this thing can be anywhere in the body of the loop. I'll be sneaky. I'll bury it. It's still there. Programming is hard because of things like this. People do this. People will sneak in the middle of a for loop something that affects the test condition. Some people will fire employees that do that, but sometimes people will think it's real clever. But people will do this, okay? So from the point of view of thinking about the outline of this stuff, you start with it, you initialize your value, and you have a test, and you have an increment, but it's entirely possible that do something has an effect on test. A wise programmer keeps the effect on test strictly over here. but that's just what a wise programmer does. There's a lot of unwise programmers, and occasionally you can write very elegant code by having the do something affect the test. It is true that sometimes you can write very, very, very elegant code by doing, but then people tend to document it real well. But you're definitely allowed to have do something affect the test, which can make the loop very hard to analyze. 99 times out of 100, the only thing that should change the test is this increment here. You should not have this affecting this, but people will do it. Okay, but it's something you should only do if you have a very good reason for it. And then you should write in big bold letters here why you're doing it. You know, you would have a comment down here saying that this piece of code affects this, and here's why I'm doing that. Yeah, but the language lets you do it that way. The language lets you put something like this anywhere in the middle of the for loop. And then now you have to say, where did I start? How am I testing it? Where do I end? How am I incrementing it? But then I also have to sit there and go, well, wait a minute. Am I sure there's nothing inside here that affects counter? Am I really positive there's nothing inside here that would have any effect on counter? Unless there's a really good reason to, this should not be anywhere inside of the body of the loop, but sometimes it is. It is allowed, and there are people who will do it that. There's times when it's a good idea. There's a small number of cases where it's not a bad idea to do this. But even without this idea, even without worrying about this, you still have to check, where did you start? How did you compare? Where did you end? And how are you incrementing by? How are you changing the counter? Are you changing it by ones or by twos? Yeah. Or are you decrementing the counter? You could be decrementing it, but now I'll have an infinite loop because I started 0. I'm checking for 9, but I'm decrementing. So now I got an infinite loop. I could change this to greater than -9. Okay, now that'll loop from 0 down to 9. Okay, I can do funny things like that. That would be a count. I could count down from 0 to -9. Okay, so, but I have to check where I started, how I compare, where I'm ending, and how I'm changing the number by. Okay, now there's another thing that we do. See how this is changing the number by 1, and before it was changing, this is decreasing it by 1, this is increasing it by 1. That's so common that this Java has a shortcut for this. You can just say counter plus plus. That's a shortcut way of saying increment counter. And counter minus minus is a shortcut way of saying decrement counter by 1. And if you want to go up by 2s, there's a shortcut for that. Instead of saying counter equals counter plus 2, there's a shortcut for that. You can say counter plus equal 2. Okay, that adds 2 to counter. So that's less than typing counter equals counter plus 2. Usually we put spaces. Normally we put spaces around those, but we don't put spaces around the plus plus. That's just style. It's actually okay to do that. But the style is, don't put spaces on the plus plus, but if you're going to use plus equal, put spaces and then put what you're plus equaling. Though you don't have to put the spaces, that's allowed, but it's a little bit hard to read. It's a little too hard to read. So style, good style is put spaces around the plus equal, don't put spaces around the plus plus. Though you see sometimes people write it that way, but most people write it that way. Okay, so you got these shortcuts. If you're going to go up by 1, plus plus, down by 1, minus minus. If you want to go up by 3s, you can. Not very common. There's up by 3s. There's down by 3s. That's pretty. Up by 2s is not unusual. Go through the even numbers, for example. You know, up by 2s is not that unusual. You're not going to see up by 3. You're not going to see for loops that go up by 3s very often at all. But every once in a while you do. Every once in a while there's a good reason to be going up by 3s. Okay, and you can go up by anything. You can go up by 10. Like, there might be good reason to go up by 10. We have 10 fingers in hand. We use a base 10 number system. You might have a good reason to be going up by tens. Okay. All right. Okay. So notice that for loop really just is a fancy way to write a while loop. And if we go back here to the outline, let me show you another thing you could do. You're not required to fill in all those spaces in a for loop. You don't even have to have something in there. You can do that. And you don't have to have something in there. So you can do that. That's a while loop. Because now there's no incrementer and there's no incrementer and there's no initializer. There's only the test. That is actually literally a while loop. Okay? All right. So if you can write, if you don't want to write the word while, you can write the word for with a parentheses, semicolon, and a semicolon parentheses, and it is a while loop. For loops are really just a special case of the while loop. Okay. And if you want an infinite while loop, you put true in here. Okay. If you want an infinite for loop, you actually have a couple ways of getting an infinite for loop. You can put true in here. But a funny thing you can do is put nothing in there. That's an infinite for loop. You can't put nothing in there. You'll get an error message if you put nothing in there. An empty thing here is not allowed. But for some reason, they allowed you to have empty for loops. So you can just type this. And every once in a while you see people, for, parentheses, semicolon, semicolon, parentheses. That's an infinite while loop or an infinite for loop. You're allowed to write that. You don't have to put any. So this is a while loop, and this is an infinite while loop. Okay, so you're allowed to type these kind of funny things. Okay, but you cannot type this guy empty. Okay. All right. Now, this is just the mechanics of for loops. Okay. The real issue is, what do you want them for? I'm sorry. What do you really want to do with them? We really want to solve problems with them. And that's where things get hard. That's where we want to really spend our time. We're going to spend, well, when we come back next week and probably the week after, talking about actually solving various problems using for loops. All we've done here is look at the mechanics of a for loop. What does this piece do? What does this piece do? This idea that you read it by coming in, doing this once, then the test, then you do this, then the increment, then the test, then the loop is right there. This is thinking about the mechanics of a for loop. What we sometimes refer to as just the syntax and the semantics. What does it mean? How do you write it? And what does it mean? But not the real question is, how do I make good use of for loops? Like, how am I going to actually solve problems with for loops? That's what we're going to be spending a lot of time on. That's actually the trickier part. Okay. I think we've done everything there is to say about the mechanics of for loops, which is summarized mostly in this thing here. Oops. This page here summarizes, compare it to an if statement. If this is true, you do this one time. If this is true, you do this, otherwise you do that. Okay, there's no otherwise for while loops, though there could be. The while loop says, while this is true, do this. Okay, so instead of if this is true, do this, it's while this is true, do this. But now you better have this guy go back and do, this guy should somehow affect this thing, otherwise you have an infinite loop. You could have an else-like thing for a while loop. People who do it are usually call it finally. If a language has it, it's written finally, but a few languages have that. Okay. A common pattern for while loops is initialize a variable, test that variable, increment that variable. So you set a counter of some kind. While the counter passes your test, do something, then change the counter, either count up or count down. Okay, that pattern is so ubiquitous for while loops that it got turned into the for loop. The for loop just is that pattern made simple. The initializer goes there, the test goes between the semicolons, and the increment goes after the second semicolon. But now you have a quirky thing. You could still have this guy affect that guy. And if you do it that way, you end up with pretty hard to read for loops. Yeah, this one must influence that. This one now shouldn't influence that because this is the one that influences it. But you're still, if you want, could have this thing change the counter. So the counter is changed here and in here. All right. You can also do funny things. You could not have the initializer. That's legitimate. A little bit funny, not too common, but you're not required to have the initializer. So maybe the initializer is up here. Okay, you're not required to have an incrementer. Well, then you're back to mostly like the while loop. Now this better affect this thing because otherwise you have an infinite loop. But you're not required to have that one. Okay, so there's all kinds of weird quirks. Okay, now one last thing. There is one subtle difference between these two. They actually are not exactly the same thing. And let me write a little Java program. Let's see, I'll close this one and I'll write a little Java program to show you how that they're a little bit different. I want to compare a while loop with a for loop. Okay. Int count1 equal 0, while count1 is less than 4, let's see what count1 is, and then let's see it again. How does count1 go up, and what's its value when I'm done? Now we know that we've analyzed this before. Count will start at 0, then go 1, 2, 3, 4, and stop there. We'll print out 0, 1, 2, 3, and then to make this one different, let me write so this is outside the loop. Now let me compare that to a for loop. For, I'm going to write the same for loop, but I'm going to call it count2. Int count2 equal 0, count2 less than 4. Now see, I'm just moving the parts around. Oh, what did I forget up here? I forgot to change count. Okay, see, I got to make sure I change count, and I want to make it after the print. Okay, so there's the count2 plus plus. And then I'd like to do this. Okay. This isn't going to compile real quick. See this count2? It lives inside the for loop. It's gone by here. It doesn't exist anymore. That's the only thing that's different about the for loop from the while loop. Because you're declaring this variable inside the for loop, it lives only up to there. It's called the scope. So I compile this, and Java tells me, oh, count1, compile this, And Java tells me that there's no count 2 because that count ended there. Whereas this guy's declared outside of the while loop, so he lives even after the while loop. So this variable being declared outside the while loop also lives outside the while loop. In the variables declared in the for loop, it only lives up to here in the for loop. So now I have to comment that out to get this to compile. And then I can run it, okay, and see that the first for 0, 1, 2, 3, count 1 was 4 outside the loop. Oh, and I forgot the little LNs there. Okay, 0, 1, 2, 3 inside the loop. 4 is outside the loop. 0, 1, 2, 3, but now count 2 doesn't exist outside the loop. So that's a minor, actually it's not a minor, it's a real important detail. Okay, so that's a real important little detail. That variable, the variable you initialize inside of a for loop doesn't live outside the for loop. Now I can fix that by doing the following. If I really wanted to see what was happening, I can do the following. I'm going to switch to account 3. But what I do, I declare it out here and initialize it in here. Every once in a while, this is what you need to do. If I want to see the value of count 3 after the for loop, I have to declare it outside the for loop. I initialize it here. This is why declaration and initialization are such important distinctions. Count 3 is declared outside the for loop, so now it lives outside the for loop. See that? Let's see, what did I do wrong? Oh, I forgot the parentheses. Okay. Okay. So now I can see that in the for loop, I actually did have 4 when I left the for loop. I dropped out of the for loop with count 3 equal to 4. I also dropped out of the middle for loop with count 2 equal to 4, but I can't prove that. I cannot print count 2 after it hits 4, because as soon as this thing is false and I leave this code, count 2 disappears. Okay, so that's the last detail. So we run out of time. So that's the last little piece of detail to for loops. Next week and the week after, we're going to be spending all our time saying, how can we use these guys to solve problems? How can we use for loops to solve problems? Okay, so I'll go ahead and stop sharing. You know, you have we won't meet again till Thursday because we have a nice little vacation. So if you have questions during the vacation, please send me an email. So if you're trying stuff out and you have a question about something, go ahead and send an email. And also have a nice weekend. Okay, bye-bye.